Matt, what up?
Seve, how you doing?
I'm
little
doing
too
great.
long.
Feels good to be back. Yeah, how long has it been? It feels like, how many have we done this year? 2? Is that right?
Oh God, I hope it's been more than that.
Oh my gosh.
It
Oh
might
yeah,
have
we've
been.
done 4 from the perspective of the viewer. The perspective of the viewer.
That's what all matters.
We're not going to leak our techniques here, but maybe we sometimes record episodes on the same day. Maybe sometimes that
We just have a
happens.
bit of a longer chat and cut it into 2 because it's a bit boring if you listen to us for 2.5 hours straight.
Very true, and you kind of got to do it because we're in the grind.
Yeah,
You know?
we're definitely in the grind phase.
Speaking of the grind, how do you feel about this Twitter movement? There's a Twitter movement right now, and it's like you can just do things.
You can just do things.
That's what people are talking about.
So people brought this up this morning. This morning I was at, it was a Boom sort of live event that YC was hosting on behalf of Boom.
Now, Boom, what is that for people who are not obsessed with Twitter?
Good idea. So Boom it's Boom Supersonic is the full name. They're a supersonic commercial airliner company. So they're making a jet. You can kind of think of a modern Concorde that the premise is the supersonic booms don't even hit the ground.
Oh, yeah.
And so you can have quiet, extremely fast, like 50% faster than today's airliners travel, even overland. So like SF to New York, for example, you do 90 minutes faster.
Whoa.
Which is pretty sick.
90 minutes faster, not 90 minutes total.
Not in 90 minutes. Not yet.
Not
Maybe
yet.
one day, hopefully soon, but...
I saw a graphic about Boom, and I guess how it works is they go high enough where the sonic boom happens, but it doesn't quite hit the ground. That's my understanding.
That is also my understanding. So they were talking about this a little bit, but and this actually happens with submarines and sonar as well. But with you have a bit of stratification. We end up with layering basically within even fluids. And so you think of fluids mixing like quite perfectly, but on an enormous scale, there's just not enough movement to actually get the mixing you would anticipate.
Okay.
And so if you have a hot layer and a cold layer, you end up with a significant change in density, and that changes the speed of sound. And the best analog for this is, have you ever done that experiment when you're a little kid? You stick a pencil in a glass of water and you've got like this offset shift in it like kind of looks broken. I'll stick my finger in my water right now.
Yeah. It's like visually the pencil will look broken. I do remember that. Why does everybody do that?
You kind of look at it from the side. Well, it's important, we've known this for millions of years because if you're fishing, spearfishing, the fish is actually not in the place you think it is.
Yeah, you got to like aim above it or below it or something like that.
Whichever direction it is.
Yeah.
And the reason that is because it's basically acting as a lens, and the change of speed of sound through the medium, or in that case, light, deflects the light's rays. And so if you have the right set of stratification, you end up just basically redirecting the sound through, you can imagine the sound lens of atmosphere, just redirecting it straight up. So it's not a bounce off, it's an arc through the atmosphere and then up again. And so they're collecting enormous amounts of weather data, the pressures, the temperatures, all that kind of stuff. And if you fly the right profile, the boom is inaudible at the ground.
Oh, wow. Because it's I guess it would be quite loud otherwise, right? Like how far away, I wonder, does a sonic boom travel? I've seen YouTube videos, but that doesn't really, you can't really get an impression from that. It's one of those things like, I guess probably most people will never experience a sonic boom, right?
Probably not. I believe they were going fast enough that it was bloody loud at the SF Air Show a few months ago now. One of my buddies happens to have a small boat. We went out sailing and we were out on the harbor, like right underneath where they're just shooting over in the SF Bay here. And oh my God, it was loud. You could see the cones, the vapor cones off a couple of them, which is often indicative of extremely high speeds.
As you get closer, it's like sonic booms, and I guess the water kind of works the same way, where it kind of like piles up or something if you're going fast enough.
Exactly. You end up over compressing the air. You end up compressing the air in such a way that the sound wave never ends up like propagating away from the front of the jet, and you end up just pushing it back to the point where it kind of just goes diagonally backwards, if that makes sense, roughly speaking.
Yeah.
Very approximate description. But we could see vapor cones on the jets above us, and they were tens of meters above us. Like they were very low, like no more than 100 meters, 100 yards for you Americans, and then 300 feet roughly. It couldn't have been higher. They were so close. And then you could see straight down the back of the jet engine as they were going up behind you. And God, that was loud.
Wow.
So I don't know if if I was experiencing true sonic booms while under them at any time during that, because it feels irresponsible to go supersonic during something like that. But even then, it's just inordinately like chest thumpingly loud, even at subsonic ranges. You're not going to break any windows with a supersonic boom, realistically. Those are kind of myths from what we can tell.
Yeah, I don't really get the whole window breaking thing because sound, like, I guess there's energy behind sound, but it would have to be a very specific frequency to break a window, right? Like, that's the whole thing with the opera singer or whatever, right?
That's a different effect.
That's a different,
That's a
it's
different
completely unrelated.
Let me just, 1 second.
Yeah.
Yes. It's recording, not streaming. Very important difference.
Yes. Oh my gosh.
I just wanted to double check.
So we're using OBS. Everybody uses OBS.
OBS, fantastic.
And that record and stream button are right next to each other.
Yep.
Yeah.
And one saves it and one doesn't. And so you really want to be sure. No, so different effects. The opera singer, is a resonance. And what that does is when you resonate with something, it's just like a LC circuit, for example. You'll end up, any noise injected in there that helps grow that resonance will continue to, and without sufficient damping, will just increase the magnitude of the wave that's propagating in the resonant thing.
Okay. So basically the energy can build.
Exactly.
Okay.
It kind of integrates, it builds.
So then the effect of a sonic boom breaking a window would be more like
punching it.
It would be like punching it. Okay.
It's a really sharp pressure wave that has a bit of a strange profile. It's kind of a straight line dip and then a sawtooth up to the opposite pressure and then straight back down to zero. And so it's this really brutal, shaking force.
Okay.
So anyway, thankfully, they don't reach the ground from the boom jets. So they've demonstrated that they don't have to.
A question about boom. Is boom I assume whenever you're doing something that seems really dangerous and physical, it kind of feels like you'd be working with the military or something, but they seem to be very oriented around just normal travel, right?
That's the thing. That's where your original question comes in. You can just do things.
Yeah.
And we've kind of forgotten that to some large degree in the civilian world, that you can just send it, And look, I think what they're doing is beyond admirable. I think it's incredibly awesome. They've set a precedent here of, yes, you can just do things.
Right.
And some countries are more amenable to it than others. I worked in Germany in aerospace for a little bit, and that wasn't quite the same here.
Right. And I think maybe an extension of you can just do it is maybe there are rules and maybe you can break them sometimes. I think Uber kind of famously sort of broke or worked around many, many rules, taxiing rules.
Yep.
But also Elon, when he was doing stuff, was a lot of times just argue against that rule because it's dumb.
Yeah. Or you can eat the punishment is an attitude you can take as well.
Yeah.
But not one that I actually think Boom's taking in this case. In that if you ask and you're forthcoming, which is how they've been with the FAA, they've been the first civilian test regime over land that's got granted FAA clearance to go supersonic, which is really cool. And it proves that you can work with these agencies if you approach things really positively. You don't act in a manner that's going to dig you down a big paper trail, then you can get things done.
And
which
I guess
is awesome.
if you're not controversial, nobody who is against fast air travel, probably no one, right? But maybe if you're a little bit controversial,
some people who really just hate air travel through and through all over. I'm sure someone hates it.
There probably are people like that because I think Taylor Swift, I want to say, got a lot of hate for flying her private jet around. So I guess
there's a limit to what's reasonable.
Right. That's fair.
But I'm really optimistic as well that with potentially some alternative fuels, and I don't mean synthetic, Jet A1, because that's a pretty boring fuel in the scheme of things. But liquid methane, like they're using in rockets, typically with SpaceX, of course. We have another friend from YC, Ian, who's started a company called Astromechanica. And if I remember correctly, they're looking at liquid methane for their fuel as well. And, they're looking at building supersonic jet engines. That's their premise, right? And so if you go down those paths, there's some incredibly cool shit you can do,
Very interesting. I didn't even think about that there's a ton of innovation in kind of liquid fuel that we haven't explored because we maybe haven't needed to, We've been too stuck in the optimization game and not enough in the inventing game. Yeah, because I guess liquid fuel, the energy density is really insane, right?
Yeah. The liquid fuels, you don't want pressurized hydrogen, right? And liquefying hydrogen's just way too hard and dangerous. And you end up freezing all your other oxidizers and just there's shenanigans involved, But you get it. But with with liquid methane, for example, you also get the added benefit that you have this cooling medium that you need to heat up in order to burn on board. And so if you're going supersonic, your aircraft gets really hot. Okay, well, pump your fuel around to your nose, which gets really hot.
Yeah.
Use the heat off the nose to boil your fuel, and now you have something that you can actually burn, because you can't inject it as a liquid. You need to inject it as a gas.
Oh man, whole thing is like a chemistry system. It's like a closed chemistry system
that you're sitting in the middle of.
Hopefully there's some electronics in there to control that stuff. Maybe there's not, though. You know, when you look at like the SpaceX kind of rocket transition over time, they love to show like these 3 images, right? Have you seen this thing?
Yeah. Oh yeah. The Raptor engines.
Yeah, the 3 Raptor engines.
What can you delete is really the question.
Yeah, what can you delete? And I feel like with mechanical systems, sometimes it feels like maybe do you think they're adding electronics, like making it smarter, or are they kind of removing it? They're like, we needed electronics or software to kind of get over something. It kind of related. I was looking at making game controllers.
Okay. Yeah.
And there's this very, very popular, I think it's called like KY49 or something like that. It's a very popular like analog stick that you can just buy and slap on a PCB.
Oh, okay. Yep.
Widely available.
Okay.
So like, you always have 2 of those.
A joystick
things, right?
as a component.
A joystick as a component.
Okay, yep.
Exactly.
Yep.
And everybody online is like, yeah, these things are terrible quality.
Really?
They're super inconsistent. You have to calibrate them.
Okay. Yep.
But everybody just solves it in software. We've just agreed that, hey, we're going to go for the super cheap and then solve it in software.
Yep.
And I wonder if maybe at the beginning it's kind of like that, but if you're actually playing the optimization game, you actually kind of get rid of your electronics. Maybe you don't, you have them there just to fix things in software. You kind of remove it as you go. But I don't know anything about Raptor engines, so.
Look, specifically the Raptor engines, I'm not hyper familiar with, but I think it's to some reasonable degree the opposite. Because we used to joke when I was at Lilium that the only team meeting their weight targets were the software team, right?
Yeah.
Right. It doesn't cost anything, right? And like this is the case with every aerospace design project. Is everyone's over budget, everyone's over time, everyone's overweight.
Yeah.
And so in software, they still had 2 out of those 3, right? But it's hard to be overweight. Yeah. And so if you can shift some complexity or gain some efficiency in software, it's practically free, right? And again, taking a look at Astra Mechanica for inspiration, if you can, there's the classic suck, squeeze, bang, blow engine cycle. Are you familiar with these terms?
I've never heard of this. Sack, squeeze. What was this?
Suck, squeeze, bang, blow. It's a very, very famous way to describe how an engine works, right? Firstly, you suck in some air, a mixture of air and fuel. You squeeze it, compression. Bang, you explode, you detonate, don't detonate it, you ignite it. And the detonation is really bad actually, but a deflagration, it burns, and then it pushes the cylinder down, and then you blow it out, and then you suck in again. And so this is exactly the same with a jet engine or an internal combustion engine on a car. And with a jet engine, you have the compression stage at the front, which is sucking in the air and compressing it. It's a bit squeezed into one, and there's typically a series of propellers that do various things there. And then you inject some fuel, you burn it, and then typically you have a set of basically fans at the outside stage. You can imagine it's just a set of gears where you have a lower gear that's easier to spin on the output and a higher one that's harder on the back. Yeah, that way around, I believe. And so the burnt mixture wants to go out the back because it's an easier route, but at the same time, it's going faster. It's got more energy, and you're decompressing it as you go, and therefore you're extracting energy that you're using to drive the compressing fans on the front, right? Now, how can you break this cycle? And what they've done at Astra Mechanica is they've only got the compression stages, because the hot stage at the back is the hard bit, right? Because you've got this thing spinning at tens of thousands of RPM that is really hot and will tear itself apart. But if you use electronics, which is what they do, to run the compressor at the start, then you can delete all of the really complex, heavy, hard mechanical things at the back and gain tens of % of efficiency at the front. Right.
Oh, very interesting.
Yep.
So really, we're talking about a future with way more integrated electronics, and it's something you said.
Tightly integrated electronics.
Yeah, tightly integrated. Yeah. So to call back like something you said a long time ago, like I guess maybe the structure will be we have smarter kind of like edge applications, right? So like maybe we have I'm describing this really poorly, but we have smarter networked like robots or whatever, right? Something to this effect.
I think you're talking about our conversation on servo drives.
Yeah, maybe, perhaps. We've done a lot of episodes at this point. I don't even know how many, but
yeah, tens, which is great. So okay, yeah, I mean, if you're gonna push, so on the servo drive front, if you can give a servo drive a path to follow rather than just be here now,
right,
you get to change where the complexity in your control system lies. You get to change how much bandwidth you need on all of your data links and that type of thing. You need to change whether or not you need a real-time controller in the center of it, or whether you can deal with a regular OS, that a non-real-time OS. And I guess it is a similar concept. If you can push things around, and being able to create custom, tightly integrated electronics, which is not a trivial thing, right? If you can do that, then you have so much more flexibility to push things into push responsibilities of a system into places that they previously weren't.
Yeah. Huh, very interesting. Oh my gosh. Wow. Okay. Jet engines, distributed electronics. We're jumping everywhere.
Same.
One thing we were talking about prior to starting was Atopile 03. 03?
0.3, yeah. 0.3 is what we're calling it. So, I mean, we use semantic versioning because we're not, masochists or anything like that.
Do you really use semantic versioning though, or do you use semantic versioning?
So I would say that we've failed a little bit with the patch and minor. We should probably push a little bit more up to major, but like the behavior before version 1 is a little bit, well, actually maybe I don't want to speak out of my ass here, but it's, as my understanding, a little bit less defined in the sense that you should use your minor as your major because you'll do breaking things fairly often.
Everything kind of shifts.
Yes, and everything's a patch. So in that case, I'd say we're done really well.
Yeah.
So
my controversial take on this is that every big project basically gives up on semantic versioning.
I think eventually.
Yeah,
eventually.
It's just like, how can you build excitement about version 18? It's impossible. But anyway,
Apple still tries.
They do. Yeah, they probably need to swap up the name here, like from iPhone to, I don't know. I don't know what the next thing would be. They really got this I theme.
They just got to see, cars are the ultimate version of this, where you've just done away with all of the version numbers and you say, I have a 2021 model, Ford Focus,
That's
RS
true.
or whatever. You pick a car, you pick the model and the year. You might even say with a Tesla, I have an early 2021 or I have a late 2021 when you're doing it a little bit more frequently.
There are people online who do that. They label their version 2025. They do it based on date. And it kind of works. But I secretly hate these projects.
Oh, okay. Yeah, hot takes. Let's go.
Yeah, because a lot of people who do this are deeply unpopular. Their packages have no downloads. And so if you take over that package because they literally never had a single user, you can't reduce the versions. You've basically trapped someone because you're not supposed to change versions on things that are already released.
That makes sense.
If they had just done 0 versions or whatever, I could just release the 1.0 and it would be a different project and that's fine.
Yeah.
But anyway, 0.3, what do we got going on here? I saw, I popped into the Atopile Discord and I saw you guys had something with I don't know, maybe you have this in 0.2, but almost I don't know what to call it, but you can keep the routes and then repeat them or something like that. Yeah. Is that a 0.3 feature? Or?
That's something that we've got in 0.2 as well. But in 0.3, so this comes down to a bit of, it's like design reuse. How do you intelligently capture your intent and then reuse that? And just let's be pragmatic about it.
Right.
I think this is one of the things I love about Australian engineers is that we're very pragmatic in general. And so having many Australians on our team, I think it biases our company a lot towards that pragmatism as well. How do we be pragmatic about it? Well, if you have a reference design for something, you have a reference layout for some IC or another, that you've got, whatever, a couple of decoupling caps and maybe an inductor and bits and pieces. The question is, do you really need to optimize that layout for your specific application?
Right.
Or can you just plop it in as a blob and dump a copper pour around it and you're good to go?
Yeah, it's not even do you like, oh, do I really need to change it? It's like, I don't want to.
Yeah. Typically, it
It's a
doesn't.
known working layout.
Hell yeah.
Yeah.
Typically, it doesn't matter in our experience. So, if you're making an iPhone, sure, you're always going to be able to come up with corner cases here. But I think part of the beauty of this is that you don't need to anywhere near as much as people think you do.
Right.
And I think you saw this a lot in software, and more recently, the attitude's just going away.
Yeah.
Right? Where people would be like, oh, well, I wrote this in assembly because it needed to be optimized. You're like, I feel like you're full of crap.
Yeah, they're full of it. They're full of it.
Often.
There's so much popular stuff happening with like UV, the Python package manager, and NPM and Rust. And it's just showing that people just want to be able to plug in things. They don't want to create everything from the ground up.
No, not for the sake of optimization, at least. I mean, UV is fantastic. We use it, we use it ourselves. NPM I use less frequently, but occasionally here and there. And I think that's the answer is, you can break norms and things, but you have to actually have some value proposition at the end of it.
Right.
And for us, the value proposition is that you can typically design your boards about 5 times faster if you're using like what we typically do as the number of as the amount of package reuse, because you barely need to do any layout, right? Which is awesome. And you're pretty confident it's going to work, which goes a long way.
I was recently browsing Twitter as usual, and I saw.
Are you okay? You're on Twitter a lot,
I am on Twitter excessively, but anyway, I was browsing and I saw Flux AI. They sort of like have, I don't know. I guess they're trying to develop an auto router, and a lot of people were really critical of the traces, but I couldn't figure out why. And my point in saying that, I even asked, I was like, talking to everyone, I was like, what's wrong with it? Tell me. They're like, oh, there's no ground pour. And I'm like, okay, fair enough. But like, besides that, right? Do you think that, like, what is the opposition to modules, right? Because it seems like people instinctively kind of don't like things.
Oh, interesting. Yeah, I think so. I think we've had nothing but positivity about modules.
Yeah.
I think everyone who's tried it has loved it. All the opposition has been, my team might not, want a schematic. Can you auto-generate a schematic? This type of thing. Everyone's loved the modularity.
Right.
It's the foundation of all good software, in my opinion.
Yeah. It's just like bringing some of those great software development practices into the hardware world.
Oh yeah.
I think one really cool thing with modules too is if you're at a really big company. And this is completely speculative. I haven't talked to anybody who needs this, but I'm speculating.
Go for it.
Maybe in 5 years I'll be right. But if you're in a really big company, you might not want one person's computer to have like all the hardware that makes up a complex PCB. There's actually a bit of risk there.
Okay.
Right?
One person's computer to
have access to how to build the entire board.
Oh, okay. You don't want to have all the IP, basically.
All the IP on one machine.
Interesting. Okay.
Yeah, where it could leak out. And modules also let you do this thing where you can say, yeah, that's a block that works like this.
Yep.
This is how you use it.
Yeah.
But we're not going to actually like ship it there. We're going to give you all the constraints to build and stuff like that.
Yeah.
But we're not actually going to give it to you. And it's kind of a cool paradigm because today there are, libraries with various licensing or software that you kind of like OpenAI. I don't have access to run their models, but I can still integrate with them. So it kind of opens up this whole frontier of using these kind of private modules that companies might not, want to release for whatever reason.
We already have this paradigm with ICs, right?
Yeah.
Like to some large degree, ICs are a black box, particularly a microcontroller, right? Like they tell you, oh yeah, we've got CPU and a memory, and you're like, cool, okay.
Right.
And you can x-ray the thing and you can see roughly what's inside, but you don't need to know the nuts and bolts, and nor would you want to.
Right. It's probably way harder to copy a chip than a PCB now that I think about it. A PCB is relatively easy to copy, I think.
Yeah, and relatively legal,
Yeah.
It's patent protected, not copyright protected, because it's not considered a work in the same way.
Yes, and I think we talked in the past, like we don't really know. We're sort of blurring the lines a little bit, I guess, right?
Yeah.
So in theory, Atopile or tscircuit code would be copyrighted, but
the code's copyrighted, but the board itself is only patentable.
Right.
Yep.
Right.
As far as I understand, I'm not a lawyer. This isn't legal advice, but as far as I understand, that's how this works. Is you could directly one-to-one copy the board, but the exciting thing about this is with Atopile, tscircuit, or JetX, or any of these code to PCB designers, these tool chains, is that you're going to have a copyrighted core. You're going to be able to iterate really fast and do awesome things that have really high quality, like unprecedented quality. Because normally when you talk about iteration hardware, people get spooked.
Right.
We're talking about quality and reliability like you will only get after the maturation of a product, but early on and consistently. That's exciting.
Right. Yeah. Literally just loading 5 years of experience of somebody iterating on a module into a project. I mean,
yeah. It's incredible. One thing you did ask about the 0.3 and the most exciting
there's
thing.
Probably so much stuff in here. Yeah.
There's a lot of stuff, right? But I think, and the design reuse is a big part of the motivation for more power in the core. So there's a huge technical focus inwards. But one of the coolest things that I think is going to be immediately exciting and available. Are you familiar with SMT solvers or computer algebra solvers?
Yeah. Wait, that's like an old. It's like an algorithm problem, something like that, right? Is that right?
Yeah, to some large degree, they're kind of like logic solvers, and they use them in type checking systems. They use them in like big compute optimization type of stuff like that up there. But also your CAS calculator. It's technically a different domain, but it's pretty similar in computer science. The computer algebra systems, the CAS calculator, you might have remember, you got a TI Inspire or the likes.
Yes, the TI Inspire. Yeah, I remember this.
A classic, right? And what they're doing in the background is, you familiar with SymPy as well?
SymPy, symbolic Python, something like that?
Exactly, yeah. SymPy is just a CAS calculator in Python, right? And what it's doing is it's doing algebra on your symbolic equations in order to, in that case, rearrange them, manipulate them. In the case of an SMT solver, it's a theorem prover, basically. You say, here is a theory, here are some constraints, is it true or not?
Right.
Like find a contradiction.
Yeah.
And what 0.3 of Atopile has built into it is a composite kind of CAS and SMT solver, more on the CAS side, where it is able to take your assertions in your equations and rearrange them, including all of the variance, the units, the tolerances, all of this, and decide whether or not your circuit meets all of your criteria. Not just for the resistors like we had before, but it's able to solve them too. And so you can say, I've got an RC filter that here's the defining characteristic. It's, its cutoff frequency is this. And now instead of just saying it's within this range and there's sort of this one-way propagation of these, it can rearrange it and say the cutoff frequency is this value. So it tracks the correlation there. It'll do the rearranging for you to solve that equation. And the rearranging is something we're increasing the power of. And so sometimes you need to give it the rearranged version, but it will be able to prove then whether or not the capacitor or the resistor does what you need it to, and thereby select components that actually meet those criteria. So you can have really robust engineering equations built into your design.
Yeah.
And it can solve those for you and figure out how to build your circuit.
That's pretty cool. So it's kind of like, I can see for like people working on audio stuff, this would be huge. Maybe power, like if you have power systems.
Yep. With a power supply, the perfect example of this is saying that you might have, an input range and an output range of voltage you're going for with perhaps some ripple characteristics, that type of thing. If you constrain those and you say that I need my output voltage to be within 3.3 volts plus or minus 5% for argument's sake, and I don't know where my my input range will be anywhere between 5 and 15 volts for argument's sake, it can configure whatever I say you have in there with the right resistors, caps, etc. Make sure that your caps voltage ratings are high enough. It'll propagate the voltages around the circuit for you. It'll propagate all this information and solve it for you in a pretty clever way.
Yeah, and it's kind of related to this whole theme. We talked to Duncan from JetX forever ago about this, but design intent, like you don't really care about that specific resistor value. You care about the thing doing something, filtering a certain frequency, whatever.
Well, the way you talk like that, right? That's the modularity back at it again. You don't even care about the resistor and the capacitor together. You care what they do in that arrangement, which is really cool stuff.
There was an article on Hacker News recently that said everybody was, and I couldn't actually assess the correctness of this, but I guess 100 nanofarad decoupling capacitors are like extremely ubiquitous. They're all over the place.
Oh, yes. I read this article.
Yeah. So you probably understood this a little bit more than me. This guy was arguing that everybody was picking 100 nanofarad capacitors. That might not actually be the right value because kind of like the math you do needs, math people are doing was just kind of wrong.
Everyone was picking 100 nanofarad capacitors because everyone was picking 100 nanofarad capacitors.
You're right. It's just like on every reference PDF and it kind of works. Like it's kind of close to the right value, so it kind of works.
And also that there's a ratio of basically inductance to capacitance. You need to have like an effective useful capacitance at the frequencies you're trying to decouple. And with really modern capacitors, which were just ubiquitous, right?
Right.
You end up with 1 microfarad capacitors, basically even across the spectrum delivering better performance than the 100 nan for anything that you typically care about.
Yeah.
Whereas previously, and still, there's a big trade-off between the amount of capacitance you have and the inductance typically. And so the sweet spot in the ratio has now been pushed up the chain, I think was one of the big arguments as well that I saw in that article.
So it's kind of like maybe 20 years ago, 100 nanofarad was good, but now it's more like 1 microfarad?
1 microfarad, yeah.
What I couldn't make out is people were really angry about this assertion in the Hacker News comments, and they were all saying like, oh, you didn't take into account this and that. And then it lost me. But the point is, if you're using Atopile, you guys will have worked out this these correct ratios. Another thing I'm curious about is the relationship between this. I think historically people would have used SPICE for maybe analyzing the analog characteristics of their circuit. But SPICE doesn't really tell you what resistor value to use. It's more like an output, right?
Yep.
So this is kind of different. It's kind of like... it's kind of solving backwards from SPICE. Is that right?
Sort of. I think the way I like to think about this is you've got sort of 2 classes of equation. You've got like a engineering equation static modeling of things. Like whatever, you've got a pair of resistors set up as a voltage divider and my output is a ratio of the, blah, 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 your resistor equation.
So there's like a spec for this, like whatever you're trying to build, there's like a spec, like, okay, this resistor, you need a voltage divider that does this for this voltage. Okay.
Yeah. And so that's what the Atopile solver can do. And that's what's super exciting. It can, delete Excel, delete your Jupyter notebooks, let the compiler deal with that all for you and prove that it's correct every time you build.
Yeah. That also sounds a little bit simpler because the problem with SPICE is you never know if you've got it set up properly, right? You're like, what temperature is the board going to be when this runs? You know?
And also because it's a time-stepped simulation, right? And so they're just emulating, they're trying to simulate reality at a really high frequency time step.
Right.
And that works for a specific set of values. But one, as you were saying before, you can't really solve backwards from there. What they do with generative designs is they basically run thousands of forward runs with, whether it's for 3D CAD or for SPICE simulations, they just run it forward with parameter tweaks and kind of do gradient descent in the same way that you would. It's similar. It's not quite gradient descent, but kind of do gradient descent, you can imagine, to try optimize.
Right.
And that's fine, but it's pretty slow. You don't want to do that every run.
Right.
It's not particularly well suited, and it only tests 1 point. So you could test 1,000 points within what potential ranges your resistor could actually be at that time based on the temperature or based on the manufacturing tolerance. But you're still, like, this is still a Monte Carlo simulation at the end of the day where you're spitballing and then getting a range out. Whereas with an SMT or with an Atopile solver, you can make guarantees about this because you've algebraically rearranged the equation.
Yeah, it's kind of cool. It's kind of like something a manufacturer could put in a PDF too, right? They're like, this is the code for the module, and now you know all the parameters people are going to pick, and you could even...
Hopefully they put it in one of our repositories.
Right. Hopefully, yeah.
Because you have a package repository that quite looks like NPN, and you can just install stuff out of as well in tscircuit, right?
Yes. We're trying to do NPM. You can literally set up tscircuit to just be NPM. We implement the NPM API.
Wow.
Yeah, but there be demons or devils or details or something like that.
There be devilish details.
Yes, it's quite complicated. I think we would only support sort of what you're saying, these sort of forward computed parameters. So you could say, this is a variable that you give a component and then it kind of sets values for you, but it wouldn't solve. So you wouldn't know about the interaction between two things.
Yeah.
So that's quite complicated. That's going to be very interesting. A sort of symbolic solver inside your EDA tool. Pretty cool.
Yeah. Thank you, Seve.
Yes,
appreciate
thank
it.
you, Matt.
Thanks for the time. Good talking to you, and I'll talk to you soon. Have a good one.
I definitely lost my... Between jet engines and electronic development, I definitely lost the thread. So apologies for that.
No stress. I was going to go on about the Electron rocket, but you know the Electron rocket?
No,
Well, put the microphone back and we'll talk
All right,
about
Electron rocket.
We're back.
Tell me more. We're back.
Sorry, Naz, cut this in. So, you know, oh God, the Electron rocket is made by, please Google this for me. It will kill me.
Okay,
it's a Kiwi
right.
company. Rocket Lab, thank God. Okay, it was killing me. So the Electron rocket, this is super cool. And this is exactly up the vein of what we're talking about with the Raptor engine simplification. These guys took it to the extreme really early. It's a Kiwi company, right? So they're based in New Zealand and they've got a big American office now because you Americans won't let them do anything for the government unless they launch it from here. And they basically have deleted... Similar to a jet engine, the squeeze stage on this to some large degree is by running turbo pumps, right? And so they pump the fuel from the tanks into the rocket engine. But unlike a typical rocket, which uses, some burnt fuel to spin those turbines, Electron uses electric motors and will jettison actually a battery pack. Yeah, exactly.
Whoa, what?
And so they're able to delete, again, this really complicated hot stage of things where you're dealing with like nasty combustion products that are trying to corrode and melt everything all the time. And you just have an electric motor that you can use to, you've got great throttle variability. You have awesome control. You can spool the thing up super fast. And you got to delete, a whole bunch of complex stuff. So... yeah.
So basically, electronics are saving the day. I think I've been disproven here that they're taking away electronics. They will. Electronics really are kind of making everything smarter and more efficient.
That's the goal.
Wait, you said it's a Kiwi company. Is that an American flag I see tucked there? What's up with that?
They've got an American. I think there might be. Oh, there's another one. God damn, Rocket Lab. Be proud of yourselves. Hell, you guys do put a lot of flags up more than most other countries,
Yeah, I don't exactly understand. Like, is it a rule? I should Google this. Is it a rule that you have to have a flag? Is it a rule that you have to have a flag in an American factory?
I don't think so, but honestly, I think it's pretty cool. I actually kind of dig it.
I like it, but look at this. FTC, they actually say explicitly there's no law.
It's just all the cool kids are doing it. There's no law that requires most products to be marked or labeled as made in the US. But this is a little bit different. This is not about in the factory.
Yeah.
But I'm quite sure there's no rule. But I do think it's cool. And I think it's cool to be proud of where you're from or what country you've become a part of if you assimilated. I think that, maybe it's something that other countries could adopt from the States a little bit. Oh, there we go. It's got the Kiwi flag up there.
Oh, yeah, we got both. Yeah,
I think they're just, really trying to sell to the American defense industry at the moment. So they, don't want everyone knowing.
I do think it's cool. I wonder why it's not a thing in software companies. I mean, I know there's like...
We're all just too woke.
There is this kind of like left-right tilt difference between software developers. If you look at most software companies, they're like generally way more liberal. And then I think manufacturing companies tend to be more right-leaning.
Yeah.
But everybody is like, it's all part of the same government. So I don't get it exactly. I don't know if patriotism is different on one side versus the other.
I think patriotism for a good while here in the States, amongst like the more liberal folks, became a bit of a dirty word, and you didn't want to have a flag up. But I think that like everyone in the country should be, proud of their country in the ways that they can be, maybe not about everything. It's not like any country's perfect. And, present that and like advocate for what they think is better for the country. But that all, ultimately means standing behind the flag of it, even when things aren't ideal for the most part,
Yeah. I'll give you, I have a slight alternate theory here.
Go for it.
I think software companies sell more worldwide.
Interesting. Okay.
I have thought about having like a flag in the background for video calls and stuff like that. And I just think about at my last company, I was selling around the world. Oh, what was that?
You think about your Russian audience. And
oh my gosh, please no. Please no. No, but definitely like a lot of people in Europe. I mean, my last startup was definitely heavily linked with the tourism kind of industry, vacation rentals, stuff like that. And it just feels like it feels a little bit strange, like I'm not on the same team as my customers in some way. I don't know if that's a correct perception, but you don't have that so much with a factory. I feel like it's a different dynamic. I think it's the
avertness of it, right? Like if you put American flags all over everything that you make, it is kind of, there's a point at which it's in the face of the person who's buying it if they don't feel the same way, whether they're in the country or not. Like, say you just sold clothes that were nothing but American flags and walked around in them all day. Right. It's just a bit brash.
Can't overdo it, but being subtle, that's good.
Like I think a little made in the US is like, why not put the flag above that when you write its origin anyway, right?
Yeah.
Or there's the made in Australia little emblem has a kangaroo on it. I think that's cool. I love it.
Yeah, that is pretty cool. Yeah. Yeah, I didn't know this, but you can't, I don't know if I already talked about this, but I was very surprised that you, I guess this is probably very offensive to say. I've never thought about this, but you can't fight a kangaroo, You're
not supposed to. It's very rude. It's like going up and punching a deer. It's just like, why would you do that to Bambi?
Yeah, but aren't kangaroos like a little bit more aggressive than deer? Deer are they're harmless, but kangaroos, they're kind of in your face.
You gotta try to punch a buck. Let's see how that goes for you.
All right, that's a good point.
It's the same thing. I mean, like they're basically just act like deer. Yeah. They're skittish for the most part. You're lucky to spot them. They're gorgeous animals, and occasionally you'll have an aggressive male with enormous nuts and bigger biceps.
I think media has done something to me because when I imagine a kangaroo...
That's X again for you.
But I always imagine it with like boxing gloves for some reason. That's why, I don't know.
Yeah, they do spar with one another. They do box with one another in the wild, and historically, at least, people occasionally boxed with them for entertainment. It is kind of like cockfighting, really. It's not.
Yeah, but it's bad. That's bad.
Yeah,
it's like punching a deer. All right, I'm with you. I won't punch a kangaroo. Yeah, except in VR, perhaps.
I'll see. Yeah, it would probably win. Just watch out. They're big animals. Big kangaroo will be 2 meters tall. So that's that's like crazy. 6'4".
That's crazy.
They're big, they're big and they're strong, and they can stand up on their tail and kick you as well.
They're muscular too. If you look at their arms, it's like, oh, that's solid.
Well, it's the legs you have to worry about because they can tip back and stand on their tail briefly, just balance on it, and then kick you. And they can obviously jump.
Yeah, they got a huge. It's such a strange animal.
Yeah.
Is it like a derivative of a deer? Like
they're marsupials. They're a different branch.
So it's more like koala kind of.
Yeah, it's related to a koala and a platypus and a wombat and.
Those are all strange.
Yeah, they're all in it together.
Are those all like native Australian
Yeah,
things?
Exactly. Marsupials as a category, I think there's there might be some marsupials in New Zealand and some of the islands surrounding Australia and Papua New Guinea. That like very small oceanic region. It's a niche animal group.
Very interesting. Huh. Okay, well, I learned a lot.
Thanks, Seve.
Matt.
Have a good
soon.
one.